Assalamualaikum and good evening to our lecturer. So today we will conduct lab 3, free convection. As you can see here, open air. And after that we need to connect the heater power cord. Ini ialah bila kita pakai T1 lain yang kita tahu ialah 25 potong ke T2. Okey, saya ada 25 potong berapa ni and T3. Okay, so right now we switch on the power. After we switch on the power, we're going to increase the power to 15 watt. After the power on 50 watt, we're going to wait for the temperature to stabilize. After the temperature is stabilized, we're going to record. Done. After we record the temperature for fin type, we're going to change from fin type to fin type and flat type. Pasang balik. Nanti kalau apa nak agak gambar apa. Dah, cabut. Okay, now we're going to do pin type and we need to Okay, now we're going to do the pin type experiment and we need to set the power from 0 until 50. Dah, bawa macam je. P1 24.2, P2 24.0.
Very good day to our lecturer and friends. Today we are going to present about Lab 3 free convection. So my name is Sasidaran Wadraju and my team members are Muhammad Shahwal Hikman bin Jasdiman, Muhammad Khairul Ada bin Roslan, Muhammad Shafiq bin Muhammad Sharif and Tanvez Yang. This is the fixed power of 15 watt of heat transfer for 3 different surfaces. We have flat plate, pin and fin surfaces. We can see at T2 for surface the flat plate is 66.9 degrees Celsius, pin is 55.2 degrees Celsius, fin is 42.2 degrees Celsius. Now T1 at duct inlet is 25.8 degrees Celsius, 30 degrees Celsius, and 26.5 degrees Celsius. So the temperature difference for plate surface is 41.1 degrees Celsius, pin is 25.2 degrees Celsius, and fin is 15.7 degrees Celsius. Now we look at power and temperature table for pin type surface. Here we can see the heat transfer surface of pin of power supply from 0 watt to 15 watt. After we record the T2 and T1 that is surface T3 and duct inlet, we calculated and the temperature difference at the right side of the table. So we can see the temperature difference for the pin type surface. For the fin type, we do the same thing as the pin type. We record the T2 and T1 temperature and we calculate the temperature difference at the right side of the table. So we can see the temperature difference of 33 T2 and T1. It is 33 minus T inlet. We can see the temperature at the right side of the table.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Syafiq BMMH3553. I will present about the discussion for the lab free convection. First, create a suitable chart for your result. Compare your result for each surface. Which surface create the highest temperature difference in free convection? What you can say about this surface? So this is the graph for our result, which is the graph for the flat plate have the higher temperature, which is 41.1 Celsius, and second one is pin surface, which is 25.2 degrees Celsius, and lastly is fin surface, which is 15.7 degrees Celsius. We know the fin type and pin type surface, the heat can be distributed to the surface and promote the turbulence within the flow channel and enhance the convection of the heat transfer, while the flat surface hardly perform heat transfer and convection of the surface, thus created a high temperature on the surface. The next question is, give an example on application of the surface you mentioned in any system that you know. The answer is heat sink in central processing unit, which is CPU.
Good evening. For the first question, create a chart of temperature against power, horizontal axis. What can you say about the graph? So, as for the graph, the first one is the pin surface. From 0 to 10 watt, the temperature difference decreased from 10.5 to 7.2. Then, from 10 watts onward, the temperature difference will start increase until it reaches 26.7 at 50 watt. And the gradient for pin surface is 1.7955 x plus 3.0182. So, as for the fin surface, as power increase, the temperature difference will also increase and it reaches 54.1 degrees Celsius at 50 watt. And the gradient for fin surface is 4.9973 x minus 0.2836.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Karadaha Biroslan and I'm going to explain the discussion number 2. The discussion number 2 is calculate or estimate the gradient for each graph. From your graph, what can you predict about the gradient for another surface, pin or fin, for this experiment? Compare the two gradients and give reason for your answer. For the gradient for pin type, we use the formula y2 minus with y1 divide with x2 minus with x1. Then we get 15 minus with 8 divide by 35 minus with 15. And we get the gradient for fin type is 0.35. For the gradient for fin type, we use the formula y2 minus with y1 divide with x2 minus with x1. Then we get 42 minus with 16 divide by 35 minus with 15. Then we get the gradient for fin type is 1.3. When the power goes higher, the temperature difference will not be as high due to the gradient has the value of 0.35. While the fin type surface temperature difference will increase a lot due to the gradient has the value of 1.3. Because the gradient slope of the fin type surface is smaller than the fin type, it will not increase as much as fin type surface. One reason is that fin type surface heat transfer more evenly and provide better convection than fin surface. For discussion number 3 is give 2 suggestions on precaution steps that you can take to minimize the time to stabilize the surface temperature. For the first suggestion is keep the gradient temperature as low while the experiment is running. The environment temperature might differ the data of the experiment. The second suggestion is air circulation must be as smooth, so it is suggested to the experiment must perform in a ventilated place. For conclusion, from the experiment, we learned that we are able to identify the different type of heat transfer surface. Flat type surface create the highest temperature. Pin type surface create the lowest temperature difference. The higher the power, the higher the difference of the temperature, and lastly, the more the heat travel, the lower the temperature become. That's all for us. Thank you.